Core Java Specialization. Overview of the curricula. Java is consistently one of the most requested programming languages companies look for when hiring developers. The LearnQuest Core Java Specialization is designed to provide you with the knowledge and skills to become a Java programmer. To be successful, we do recommend that you have some prior understanding of programming in some language. If not, LearnQuest offers a beginning programmer specialization that can help you prepare. This specialization consists of 4 courses. Now, this is LearnQuest's core Java specialization. There are other important Java topics such as database connectivity, testing, Jakarta EE, Spring, and all are covered in other LearnQuest Java specializations. So 4 courses make up this core Java specialization. Introduction to Java will introduce you to the Java offerings and cover the basic fundamentals of the language. Introduction to Object-Oriented Programming with Java provides a basic refresher on object-oriented programming and enables you to start building classes, creating objects, and understanding how solutions are packaged in Java. Object-Oriented Hierarchies in Java goes deeper into applying object-oriented programming. You will learn how to implement inheritance and polymorphism in Java. And finally, using the Java SE class library teaches you to use selected parts of the vast SE class library, such as collections, handling file I/O, and more. My name is Noel Bergman. I have been an active programmer since the mid to late 1970s and working professionally since that time. I've written real-time operating systems, email servers, distributed object programming platforms, and more. So far, I was an early adopter of Java, to which I have made contributions to several specifications and implemented many projects. A core tenet of my decades-old consulting business has always been making sure that our clients became self-sufficient on the technologies we used. And now I look forward to teaching you as you begin your Java journey. Welcome to LearnQuest's Core Java Specialization, Course 1, Introduction to Java. This is the first of 4 courses that make up LearnQuest's Core Java Specialization. Prior programming experience is recommended before starting this course. This course has 3 modules. The 3 modules that make up this course are Introduction to Java, Java Language Fundamentals, Types, and Java Language Fundamentals Flow of Control. Over the course of those modules, you will learn about Java's benefits, to program in basic Java syntax using Java data types, and to incorporate branches and loops. Welcome to Object-Oriented Programming with Java. This unit is an introduction to Java, benefits, the products, and tools. Learning objectives for this unit include an overview of the benefits of Java and a brief discussion of the 3 core offerings of Java, the Standard Edition, the Enterprise Edition, and the Micro Edition. Some of the key benefits of Java are the ability to write it once, run it anywhere, the ability to develop object-oriented solutions, programming in a familiar C or C++ based syntax, the availability of a rich set of libraries, built-in levels of security, support for internationalization, high performance, the ability to use Java at no charge, and a community that continues to evolve the rich Java ecosystem. The ability to write once, run anywhere. I can build a Java application on my machine and it can run on any other platform. It doesn't matter if it's Intel or ARM or mainframe, Windows or Linux or Solaris or Mac OS X or ZOS. Java isolates the Java application from the specifics of the physical platform on which the code runs. We write our code to the Java platform, not a specific platform. The code itself is not compiled into Intel code or ARM code. It's compiled into an architecture neutral bytecode that is part of the JVM specification. It is the JVM at runtime that will translate those platform neutral instructions into native machine code. Initially, that code might the bytecodes might be interpreted because compilation is expensive. But the JVMs themselves, the more you try to execute that code, the more effort they will put into optimizing the native code that it has been converted from the architectural neutral code. That is the job of a JIT, or just-in-time compiler. So, you start with a Java source file that runs through the compiler into the Java bytecodes, platform neutral. When that is eventually chosen for execution in a Java runtime environment, there is a verifier that will validate that the bytecodes look good and have not been tampered with. There is a class loader that will load the classes, because that's what we're going to be defining in Java, or Java classes, object orientation, into memory. And then as we execute, there is a just-in-time compiler that will translate that Java bytecode into platform-specific native code. The Java libraries that I write my Java code to for dealing with things like files or graphics or network sockets or whatever else it is that I need to talk about will then bridge to the underlying operating system. I don't have to worry about the operating system. I write to Java, and it is the Java libraries that are responsible for making it work on whatever particular operating system I'm running on. This gives me great portability. That is the core philosophy of write once, run anywhere. My compiled code can run on any JVM of the right version, on any hardware and software platform. While it does not completely isolate me from my platform, Java does a particularly good job of it. Throughout the courses that we will be covering as part of this specialty, we will be looking at many Java classes. Those classes are organized into packages. Think of a package the way you would look at a directory. You can have many files in a directory, just as you can have many classes in a package. It's just that directories are platform specific, and Java wanted some form of platform neutral understanding. That is the role of a Java package. In a file system, we might use slashes. Windows uses backslashes or can actually accept forward slashes. Other systems want forward slashes to separate the parts of a directory path. In Java, we use the dot. So com.learnquest.calculator.util. So we would be talking about a com directory with a child directory of LearnQuest, and then a further child directory of calculator, and then a final child directory of util. Real-world Java programs may use dozens or, as they say, hundreds of individual classes, each class packaged into a file. Packages help us group these classes in meaningful manners and help us also to avoid name collisions. After all, here you see a calculator. How many different companies might have created something calling it calculator? That is why the standard is to use your domain name reversed. If you are learnquest.com, you start with com.learnquest. If you are Coursera, it would be com.coursera. If you are some other company, or for example, the Apache Software Foundation, org.apache. Java was developed by Sun. Sun was one of the major Unix vendors with Solaris. Many programmers were familiar with C. At the time Java is being developed in the early 90s, much of the industry is developing in C and C++. So Java intentionally borrowed the syntax that developers were familiar with and the data types that developers were familiar with. Integers, floating point numbers, double precision floating point numbers, characters and bytes, and other. Now, these are known as primitives. Ints, floats, doubles are primitives. Java also provides object representations called integer, float with a capital, double with a capital. So for each primitive, we will see that there's also a wrapper class. In terms of programming statements and structure, it is very much the similar as C, with some things borrowed as well from C++, such as exception handling. Many of the statements, many of the keywords and operators are taken straight from C. Java comes with a rich set of libraries. String manipulations, calendars, text handling, XML parsing, and many other things. Some are part of the standard distribution, which is large, and then there is a even larger ecosystem for Java with many offerings. There are standards for our libraries provided by the Java community process. This is a gathering place of originally Sun as the developer of Java, now Oracle, and many other parties such as IBM, such as the Apache Software Foundation, such as Red Hat, and other interested parties, whether corporations or even individuals, who wanted to contribute to a standard. So the Java specification continues to evolve through the Java community process. And this does include standards. For each standard coming out of the Java community process, there will be a TCK, a kit for helping to verify compliance with the standard. There is extensive documentation for Java using something known as JavaDoc, which is a standard for how we produce documentation for Java classes. As we go through the courses, we will often be looking at the JavaDoc for various standard classes. We will look at the JavaDoc for string and other classes. One of the major areas that we have support for is database connectivity. This is done through something called JDBC, Java Database Connectivity. That is in the java.sql package. There's also a javax.sql package. The Java SQL is part of the standard Java distribution. The javax.sql would be part of the Java EE distribution. The beauty of JDBC is it allows me in that write once, run anywhere mentality to write one set of code that will talk to any SQL database for which there is a driver. It is the JDBC driver that bridges between my code that doesn't care about Oracle versus Darby versus MySQL versus DB2 and the specifics of talking to them. Now, there is a certain limitation here. Since JDBC does work by sending SQL strings, SQL, whatever string you use must be understood properly by that particular relational database. Fortunately, we do have standards, and for where those standards may fall short in terms of vendor adherence, there are some tricks that can be used to even figure out which SQL string I need depending on which driver I'm going to be using. We would like, of course, to avoid that so that we can have proper write once, run anywhere. Here's the idea of JDBC. My application only cares about the Java SQL connection. It is the vendor that provides an implementation of that interface. So here we see the example of MySQL providing an implementation of the connection, and it talks to the MySQL database. Security. There are many layers of security. One that we will just mention now is the bytecode verifier, that the bytecodes in the compiled .class file are in fact valid. Internationalization. Java uses Unicode. So again, write once, run anywhere across the planet. Not only does it use Unicode, but Java includes in the standard library the ability to store via key value pair in files the identifier for a message and the actual locale specific value of that message. So if I want to write an application that can be used in both, let's say, English and Dutch, I would use identifiers in my code rather than the literal strings. And then when I go to use those strings, I would at runtime use the framework to look up for this message identifier and the locale I'm currently running in, English or Dutch, what is the string from the file for that code and this locale. And that will be handled for us by Java. Performance is excellent. Java originally was, as they say here, 20 times, more than an order of magnitude slower than native code. The performance of Java in a modern JVM can not only meet native code, it can potentially exceed it because of tricks that the jitters can play to even further optimize code at runtime based on analysis of how that code is running. Now, Java's licensing nature is a little murky at the moment with the acquisition by Oracle. Java, the language, is not open source, it is owned, but there are open source implementations of Java. And in the next unit, we'll be installing one. Okay? So, OpenJDK, Sun, prior to being purchased by Oracle, open sourced Java as OpenJDK and put it under the GPL, which is an open source license. So there are open source implementations that you can use, not just commercial licenses that are royalty free, but actual open source implementations of them. Now, regardless of the question of open source on the libraries, the source for the libraries, that the standard ones, has always been part of a Java developer's kit and something that Java developers spent a fair amount of time looking at. Now, this is one place that you could look to download. In the next unit, we will actually look at an alternative. We will download, install, and run a little bit of Java. Java is available in 3 distinct editions. The Standard Edition, which is what many people think of when they think of Java, which includes the language, the JVM, and the core libraries. The Enterprise Edition. The Enterprise Edition is not so much an extension of the Standard Edition. The Enterprise Edition is an application server framework written using the Standard Edition. So Java Enterprise Edition is a application server with some additional libraries, but first and foremost, an application server for handling web components so that you can write dynamic interactive web sites or services, and a business logic side, the Java Enterprise Java Bean side, where we have business logic in a managed environment. There'll be more on that in a separate course later on in this curricula. And then there's the Java Micro Edition. The Java Micro Edition, most developers have never seen. It did not do well in the mobile area. Android would be the most popular Java-based mobile platform by far, as well as the world's most popular mobile platform by far. Where Micro Edition actually shows up is on your Blu-ray player. Every Blu-ray device has Java Micro Edition built in. It is actually Java coming full circle, because the original target for the Oak project that became Java was in fact set-top boxes for interactive television. That came full circle with the adoption into the Blu-ray technology of Java Micro Edition. For those of you interested in such things, it also explains why Microsoft initially was supporting the competing standard to Blu-ray and so reluctant to adopt Blu-ray. So the Standard Edition is underneath everything else. It is where the core runtime lives, the Java runtime environment. And there is a JDK, the Java Development Kit for programming. Some of the key tools: Javac or Java-C, depending on how you want to pronounce it. That is the Java compiler. Java is the entree to running it. When I want to run a Java application, I will say Java, and then I will identify the entry point to the application. JavaDoc is a tool for generating Java docs from a Java file that has the appropriate comments in it. And there is a Java debugger, which is exceedingly rarely used because we would generally be using a modern development environment with its own integrated debugger, such as Eclipse, IntelliJ, or NetBeans. Now, if you are not a developer, you can get a hold of a standalone JRE that does not include the JDK. And that can be used to run most applications. However, for a Java EE environment, there are some specific use cases where even what you would think of as a plain runtime environment requires a JDK. But that is outside of our conversation for now. Just want to make that clear.
Java Enterprise Edition, Java EE, now known as Jakarta EE, is a specification for building enterprise-level applications. Application servers, such as Wildfly or Glassfish, implement these specifications. The application server hosts various containers, such as a web container, which runs Java servlets, Java server pages, JSPs, and other web-related components defined by the specification. The application server includes an Enterprise Java Beans EJB container, which hosts EJBs. Some EJBs, such as message-driven beans, can interact with the Java Messaging Service, JMS. Most of the features of the Standard Edition, Java SE, are available in the Enterprise Edition, Java EE. However, certain features, such as direct threading control, are restricted for use by the Java EE application server. The Jakarta EE API is an umbrella that is vast. It includes support for database connectivity through JDBC, remote method invocations, what in other languages we would consider an RPC call, remote procedure call, the ability for a client to invoke a function that's actually running somewhere else. There is Java naming and directory interface. This is a layer allowing us to do lookups, such as with an LDAP server or even a regular directory server. There are extensions to JDBC that are specific for Jakarta EE. There are EJB's servlets, which provide web interface. Technically, if you read, you'll find that the servlet API was supposed to be agnostic to what protocol, but it is almost exclusively used for the HTTP protocol. Java server pages, a way of writing HTML with embedded references to Java so that page designers can produce beautiful-looking interactive web pages without reliance on Java code. In modern Jakarta EE use, we're moving further away from the use of any view technology, such as JSPs or Java server faces or anything else. We are working in a world where it's more going to be something like Jakarta EE delivering an Angular front-to-end into the browser. Then that Angular front-to-end will be communicating back to servlets to transfer data. If you're in an environment which supports asynchronous messaging over some backbone, such as TIBCO or IBM MQ or related, that is what JMS is for. JMS does for messaging what JDBC does for databases. It is a vendor-neutral messaging API that sits on top of a vendor-specific provider that's the driver. Just again, following that same notion of vendor neutrality, there's JTA, a Java Transaction API. We don't care what transaction manager you're using, that is the job of the layer between the standard API and the vendor-specific transaction manager. There is a framework in Java for dealing with SMTP and IMAP and POP called Java Mail. Java Mail, you might have attachments that are MIME types. The Java Activation Framework, odd name, but what it really talks about is how to handle MIME types in Java. That's the standard way. There are many other frameworks for dealing with MIME, arguably better than JAF, but JAF is the original and standardized way of doing it. For parsing XML, there's JAX-P. There are many different parsers. They all have their own APIs. JAX-P is the standard API that we would now expect a parser to provide support for. Whether it was be Crimson or Saxes, we would expect JAX-P support. Java Connector Architecture is a way of describing how to manage connections, going outbound or inbound. In many app servers, JDBC and JMS both use JCA under the covers to manage connection pools, to understand when there's an incoming message connection, where does it get routed, and other sorts of behavior. So, Java connector architecture would talk to those various aspects. Finally, in the security area, we have Java Authentication and Authorization Service, which has often been described as PAM for Java. It is an extensible, pluggable module that allows us to talk about not where did the code come from and does it have the right signatures, while allow it to run it all, but it allows me to talk about who is the user, what groups are they in, what rights might they have. So that is the purpose of JAS. How do I log in a standard way? Also, how do I authorize for individual users?
The Micro Edition, as I mentioned earlier, is primarily found in Blu-ray devices. You are unlikely to find it at this point in time in 2020, as I'm delivering this presentation, anywhere else.
In this lecture, we'll briefly talk about and demonstrate how to install a Java Development Kit, JDK, on your local system. You could also install just the Java Runtime Environment, JRE, if you don't need the full JDK, but note that the JDK includes the JRE. Here in the directory, we can see 2 JDKs and 2 JREs. Technically, there are 4 JREs because each JDK includes its own JRE, but we have both the standalone JREs and the ones bundled with the JDKs. Let's now move forward with the installation. I've gone to Adoptium at adoptium.net, which is the new home for the OpenJDK builds that were previously available from Adopt OpenJDK. Adoptium provides open source builds of OpenJDK, the official reference implementation of Java. When downloading Java, we recommend using a long-term support LTS version, such as OpenJDK 8, which will receive bug fixes and updates for a longer period. Non-LTS versions are available too, but they won't be supported as long as LTS releases, so they are generally not recommended for production environments. However, if you're exploring Java or working on non-production projects, feel free to use the latest non-LTS version. There's also a choice between the Hotspot and OpenJ9 JVM implementations. OpenJ9 is an alternative to Hotspot, developed by IBM and open-sourced as OpenJ9. For the purposes of this course, we'll be using OpenJ9, but here I'll demonstrate the installation of the Hotspot version. Open JDK Setup Wizard. Accept the license and decide what it is that you want to install. I will ask it to set Java Home. I will not be registering with Oracle. I will not be installing web support through Ice-T, and I will tell it to install. Once installed, I can run the command line. There it is, OpenJDK 1.8.262. Having installed OpenJDK, you'll notice that I have now expanded out program files. Adopt OpenJDK, here's the version we installed. And sure enough, there is the JRE underneath the JDK. If I look in the JRE, there is a library and a bin directory, as well as licensing information. In the bin directory, one of the things that you see is Java, that is for running classes. And in the JDK level, there is Java as well as the Java compiler. There are libraries seen here that are used for the tool. However, most of the libraries are going to be located here because that is, after all, part of the JRE. So we have now successfully installed a Java runtime. We've installed their own. We've expanded it out to see what's in there. We've taken a brief look at the bin directory for the JDK. Some of the important files: Java for execution, JavaSeq for compiling, the JavaDoc. jar files in Java are all zips. The jar program is actually a simplified zip tool, because all of the various types of structure files that we use in Java, whether they're jars or wars or ears or any of these other Java archives, are all actually in zip format. If you're running on a non-Windows system, you wouldn't have the .exe suffix, the .exe extension. You would just have Java, JavaC, JavaDoc, jar, etc. To run Java, we can do it from the command line. Now I will do a quick little demonstration of doing a hello world and running it from the command line. I have created here a simple Java version of the classic Hello World program. It is a class named Hello and a file called Hello Java. We'll learn about the structure of these classes and the programs in upcoming lectures, but for now, let's just focus on asking it to print line Hello World. Back here on the command line where I had verified that Java was installed, I will now go ahead and run Java C. Hello.java, and it has run. And there you see hello.java and hello.class. I can say Java hello, not with a class, but just a Java hello. There is the output. We have now successfully installed and executed a Java program.
Object-oriented programming with Java, Java language fundamentals, types. Our objective in this module is to first learn a little bit of Java language syntax, but primarily to understand what Java primitive types are, why we have them, what do they do, how can we work with them. Now, before we can really do anything in Java, in order to run Java, we have to have an entry point. So we're going to learn a little bit about the structure of a Java program, a little bit about the statements that provide our program with its functionality. One of the things to know about Java statements is they end with a semicolon. So, let me write a Java program. Well, where do I put it? Well, I'm going to put it into files, but you can't just arbitrarily put Java code into files. First, we have to understand, and we'll see example coming right up, that we cannot write code or place data in Java anywhere other than inside a class. Java requires that everything be inside a class. Now, we can have many, many classes, but you can't have anything that's not in a class. Now, a lot of the times, we're going to write Java code that will not run by itself. Let's say I created an employee class. What's the point of running it by itself? But when I run it in an overall employee management system, well, now my employee class has a value. So a standalone program means I've got a program that includes an entry point, a main method, and they put it in quotes, but really, that's its actual name, main. A main method, and that's where Java will start running. It is the instructions in that main method that cause everything to happen. We start by running there, and whatever main causes to have running as we branch out is what will happen. Now, if I try to run a Java class, which is what we're talking about, remember, again, everything in Java is in a class. If I try to run a class that doesn't have a main method, there will be an error. Java will say, I can't find the main. So a program is really just a Java class with a main method. Here we see a simple example, just like what we saw in the previous module. So the example is Hello World. This is the class, public, so it's visible to the runtime as opposed to being private to some use. A public class named Hello World. In order to have this class recognized by Java, it must be in a file called helloworld.java, and case counts. According to the naming convention we'll talk about shortly, classes start with an uppercase character, and if I have multiple words, such as hello world, and those are two separate words, when we put them together, we preserve the words are separated by uppercase letters. And this must go in a file called helloworld.java. Must match exactly, including the case. Doesn't matter that you're running, let's say, on a Microsoft operating system with NTFS and they don't care about case. Java does. Mac OS X will, Unix operating systems will, others will, and Java cares about case even if you're running on a file system that maybe doesn't. So please be aware of that. Everything in Java will be case sensitive. Now, here is our main. There it is. And it has a very specific, what we call signature, that it must match. It must be public so that it's visible to the Java runtime. It must be static, and we'll study later on what that means. But basically what it means is I can do this if all I know is the Hello World class. I don't have to be able to create an instance, an object from that class. For something that is our entry point, it has to be static. If it weren't static, well, what would have created the thing that came before it? So an entry point here must be static. Void means it doesn't return anything. The name must be main. Now, if I were to run this off the command line, I could provide arguments, parameters to this program. Those will be passed into us as a string array. For those of you who might be familiar with programming languages like C, where they also tell you how long the array is, we don't need to do that. One of the things about Java is we can simply ask the args array, how long are you? How many entries do you have? So all we really need is a string array. That's what the square brackets mean. Don't worry about memorizing this. We'll come back over this as we hit these things up formally later. Now, the function itself, this main method, is delimited by these braces. Inside the braces, here's a single statement, system out print line, and the string hello world. So this is simply the means by which I get the ability to print to the standard out. The method is delimited by the braces. The class itself is delimited by braces, and that is the entire content of this program. This is a complete Java program that will print hello world if we were to run it at the command line. Whenever you want to run code, you will probably want to have a main method that at least can exercise that code. Now, I am going to launch Eclipse, accept my default workspace. Now that Eclipse is running, I will close the welcome that I get from a freshly started workspace, and I will go create a new Java project. I'll give it a name. My project name will be Demos, and I'm done. Eclipse is offering to put me into a perspective, a organization of tools for Java development. I've said yes. I will now right-click on Demos and indicate that I would like to create a new class. I'm going to call it Hello World. Now, by default, that would be created without a package, which means it'd be created at some sort of root directory level. We want to organize and control how our things are placed in file systems. You'll notice the message up here, the use of the default package is discouraged. So I'm going to call it, based off of the domain name for LearnQuest, com.learnquest. And now I'll put whatever I want. So I'll call it Demos. I will tell Eclipse that I would like to have a main method. I will click Finish. It has created the package. It has created the file with the correct name. and it has brought me into an editor. I will remove this comment that was placed automatically by the blueprint with the one line that we've discussed, system.out. Notice how Eclipse is helping me type. It knows maybe what I'm looking for. I want print line, and I will say hello world. And this line has an error. You'll notice that. And the error is we have not yet put the semicolon on the end. I have put the semicolon on the end, and this program is done. I will click up here to run it. And here is my result. And notice I don't like that because it's a hello world without a space. Look how nicely I can just go up here, edit it, save it, run it again, and there it is, hello world. So that is a quick run through Eclipse, which is the environment we will be using for all of our work. Now, you saw hello world. You saw main. These things have names. So names for classes, for objects, for the different properties of them. A name is a sequence of numbers and letters and underscore. One limitation, the name cannot start with a number. It must start with underscore or a letter. All names are case sensitive. As in the case of hello world, we use camel case, upper camel case, which means the first letter is uppercase and individual words of this concatenated name are also uppercase. So hello world with a capital H and a capital W, car dealer, one word, car dealer, with a capital C and a capital D. Other names will generally start with lowercase letters, and again, following the rule about concatenating words, if we were to do so, such as set manager, the S would be lowercase, but manager would start with an uppercase M. Set manager, lowercase s, but uppercase M. Constants, however, which we will, in Java we call them finals, constants are completely capitalized. So because they're all uppercase, we would use underscores to separate the individual words. Now Java does have reserved words. There are a number of them. They're representing the primitive types that we're going to talk about. They represent the ability to talk about classes, the for loops, and other things. These are words owned by the language. We cannot use these words at all as identifiers. Right? You may recognize, for example, static, class, public, and void. But not string. String is not here because string is not a reserved word. String was the name of the string class. We can put comments in our source code. Now we have two different kinds of comments that we can work with. One is a double slash. That's the example here. It's a single line. / instance variables. Or / current speed. Comment doesn't have to take over the whole line. It takes over everything from the double slash to the end. So these are single line comments. Multiple line comments start with a / asterisk and eventually end with an */. We see the example here. This is a multi-line comment. Now notice it starts with /**. That is a special form of multi-line comment that we have a tool, a program called JavaDoc that would look for such comments in our source code and extract them to provide the documentation for that source code. So here is an example of those comments. This is just an impromptu video to demonstrate to you the lab environment. Now, the lab environment we've set up is a lightweight but otherwise complete Linux environment running Eclipse. One of the things that you'll have to do, because it is a graphical environment, is you will probably want to adjust the display resolution. And you'll have to do this whenever you go into the environment and unless you like the default resolution. So the lab instructions here are going to explain it, and then I'm going to demonstrate it. So you would open the lab and go up to the Applications menu, to Settings, to Display, and you will select from the menu, from the drop-down, the resolution you particularly want to use. Conveniently, this is highlighting the one I will select of 1360 by 768. It is defaulting to 1920 by 1080, I believe. We'll go take a look in just a moment. But you will be able to select whatever resolution from the list you is most comfortable for your environment. Okay? Once you've selected the resolution, you'll click Apply, and we'll see the graphical environment change. So having discussed that, here we go. And it takes a moment for the browser to be processed. We are now connected to the environment. Eclipse automatically launches. Okay, so Eclipse is automatically coming up and waiting for me to get started. I'm going to leave that go for now. Come to Settings, come to Display. I'll drag this up just to show you. Right? It is defaulted to 1920 by 1080, and I'm going to select 1360 by 768. Click Apply, and the system has adjusted its resolution. It is a perfectly nice width for me. Still have a little bit of height here that I might want to eliminate, but I'm good for now. And you can adjust your environment accordingly, according to whatever your hardware is and whatever browser resolution you can connect to. Okay? Now, in Labs, you will go ahead and launch Eclipse. What I'll demonstrate now is that when you're done with a lab and you close Eclipse, for in this case by canceling it, that will actually close the lab environment. Okay? This lab environment is keyed by Eclipse running. As long as Eclipse is running, I can access, parts of the lab environment. Once I close Eclipse, the lab will automatically shut down. Okay? So this is our environment for developing in Java with Eclipse for this course. And that'll be the end of our demo. You'll notice how we're automatically disconnected. Java uses several different nesting structures. Outermost blocks, such as classes, interfaces, annotations, enums, and the upcoming record structures, you can have no more than one public such structure in a file, with that file name needing to match, including case, the name of that public structure. So these are things that will contain other constructs, such as data, such as methods, even the ability to nest classes, interfaces, annotations, enums. Those are more advanced topics for later. For right now, we're going to focus on primitives and then arrays. Now, primitives, as the slide says, are places to hold data. In fact, they're the only places that Java can hold data. Right? As much as we talk about having more complex objects like employee or farm or car or bank account, when it comes down to it, the only place that Java can actually hold data is in primitives. Now, we have a number of them. We actually have 9, and I'll explain to you the one that's if you will, technically missing. We have them in different sizes. So for numbers, for whole numbers or integers, we have 8-bit bytes, we have shorts, we have ints, and we have longs in the different widths. And it does not matter whether you're on a 32-bit operating system, a 64-bit operating system, or anything else. Java specifies a virtual machine, and these primitives are the same regardless of the real machine because they're defined in terms of the virtual machine. We have 2 different floats. We have single and double precision IEEE floats. We have Boolean, and we have character, 16-bit Unicode characters. So now we're going to look at the details of these. Right? So integer types, as I said, we've got different widths. Bytes, shorts, ints, and longs. We'll have a table very shortly going into the details for each one of these primitives. Now, when we perform mathematical operations, as it says, arithmetic expressions. In other words, when we do add, subtract, multiply, and divide, we're doing it on primitives. And performing some of these operations can lead to exceptions, such as a divide by 0. Now, what exceptions are, how they get thrown, and how we might catch to handle them will be covered later in the course. Now, important points here. For one, the integer will assume that literals are, the compiler assumes that literals are integer values. If you want to explicitly declare a long, you would say so with this L suffix. Now, it's not necessary to do that. The compiler can make certain conversions for you without, but it won't always, as we'll see in an upcoming example. So good to know about the fact that it assumes that they're integers. It can widen them to make them longs. But if you need to explicitly specify that it's a long, you suffix it with an L. Real numbers. Real numbers are IEEE standard, floats for single precision and double for double precision. And the system does include the notion of infinity and not a number. Something that's just not a number, mathematically. Now, this is a bigger deal than the one with float. Real number literals default to double. If you want it to be a float, you have to say so. And I will show you in the upcoming example why that's actually arguably more important to know than the issue about integers defaulting to just plain integer and the L suffix for long. Now, to create a primitive, like we would create any other variable in Java, we specify the type and then a space and then a symbol such as int space x, and then we're done, semicolon. We can say Boolean space is started, semicolon. Now if I want to have more than one of the same type, I can put a comma separated list. Int x comma y comma z, right? Here's my x, y, z. Or Boolean is started is acceptable. We can also, by the way, assign values to these things. I could have sent int x equals 5, semicolon. Now we can declare primitives anywhere in our code. Now, when we say anywhere, it still has to be inside of a class, but it could be inside of a class, it could be inside of a method, it could be inside of a block inside of a method. And where you put it impacts where it can be seen. Primitives that are declared inside a code block delimited by braces are only visible inside those braces and are only visible within those braces from the time they are declared until the end of that block. Now, we do have some naming conventions. We've already looked at these. So, since we're declaring variables, the use of variables, whether primitives or otherwise, variables and methods will share the same naming convention. So we are using lower camel case. We talked about that earlier with the example of set manager. Here is number of doors. That's 3 words, right? Number of wheels, also 3 words. Notice that the first word starts with lowercase, unlike the class, which started with uppercase. Lowercase, and then the individual words are delimited through the use of a single uppercase character. Okay? Now it says for finals, well, if you remember, finals, which we think of as constants, are all uppercase. So we couldn't use capitalization to delimit things. Instead, as we saw in the prior lesson, we use underscores to separate them. And that is sometimes known as snake case. Thinking of the shape as a snake, winds. That's why they call it snake case. Just like camel case is named after the humps of a camel. So we say primitives here because we haven't gotten to anything else, but this will be true of variables in general. Now you can initialize primitives when you declare them. If you do not assign a variable to a primitive, Java will give it a default value. That default value differs from the type of variable that it is, but it is in general a type of primitive, but it is in general whatever 0 would mean to it. Right? So a 0 for a number, 0 for a floating point number, 0 for a character. It would default to whatever 0 means. But we can provide our own default value when we declare the thing. So here, private int number of doors is 2, private int number of wheels is 4. Now, we could do this in this class, but usually we will initialize these things not where we've declared them, but in constructor methods. And that'll be covered later in the course. For now, you can certainly initialize them this way. So this is a table describing the range of primitive types. Boolean, it's only 1 bit. It's either on or off. It's either true or false. And the default value is false, which is how a 0 would be interpreted. You'll notice that everything here, the default value is effectively what would 0 mean to that type of primitive. Okay? In the case of Boolean, underlying, even though you can't talk about it that way, 0 would be a false, or false would be a 0. And setting the bit would be a true. And those are the only 2 values you can have, true and false. Characters, right? Default, again, is all 0 in Unicode. There's the escaping here. And this is the way of representing a character using a number, /u, and then a Unicode value. There's 16 bits. They are unsigned because they're characters. So we go from, it's basically indexing into a huge character set. So from all 0s to all Fs. For numbers, however, there are no unsigned numbers in Java. Bytes do not go from 0 to 255. They go from negative 128 to 127. Remember that because I'm going to show you where the compiler will yell at me initially in my little demo because I tried to assign 128. Maximum value is 127. Okay, so signed values, and these are the ranges for a byte, the ranges for a 16-bit number, okay, negative 32,768 to positive 32,767. I'm not going to read any of the other ones out to you, right? Here's your int from 32. Here's your negative to your positive. Just as an aside, you'll notice that the negative is always one more in absolute magnitude than the positive value, just having to do with how numbers are encoded in binary. Here are longs at 64. So again, bytes were 8, 16 for shorts, 32 for ints, 64 for longs. Floats are a 32-bit mantissa, and then you have your exponent, and doubles are 64. Okay, this has to deal with the available precision of your floats.
Okay, so having completed using primitive data types, you should have at this point a lab2.java file inside com.lq.exercises package inside your source of your class exercises project. In here, you should have your public class lab2, your main method, which is a public static void main, and a number of variables defined. I have here width, height, area, radius, pi, and result, 3 of which have initialized values in the declarations, 3 of which don't. The ones that don't have them in the initialized declarations, I defined afterwards over here, which is fine. I also defined a couple of arrays, as you can see, for the number of days in month, as well as the month names. And I initialized the days in month as well. And then I have a whole bunch of print line statements and when I run the whole thing, I run it as a Java application, so right click, run as Java application, and as you can see, it results in the expected output. Okay? And folks, that's what you should have after you complete this lab on using primitive data types.
Now, our next little topic here is the notion of an array. Okay? So, an array has a size. I create an array of ints. And now, however many I've allocated, I can put ints into the boxes of the array. Okay, so arrays hold elements of a type. That's what they mean here by a grouping. And it says it can define a grouping of primitive or objects. Actually, an array only holds primitives. Whenever we talk about objects, it's like that last slide when I said we say integer, but what it really means is an integer reference, which is an object reference, which is the 9th primitive type. Okay, so we have the various primitives we've been talking about plus reference. And arrays can hold primitives, or when they say they hold objects, they really mean they hold references. Think of references like a pointer. Okay? Now, in an array, it's accessed or referenced by a number. That is its index. And indices start at 0 and go up to one length than this, one less than the size of the array, the length of the array. No, one less because we start at 0. So if I have an array of 10 things, it's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it may take you some time to get used to that, but that is the way arrays work in Java. It's 0 to one length, one less than the length of the array. Now, an array in Java is actually an object itself. So how am I going to have access to an array? Through a reference. So here we have my int array. And it says that is in here it is int array. So this will be an array of int primitives. So my int array is going to be a reference to a chunk of memory that will be treated as an array of int objects. Okay, each cell of the array will hold an int. Now I don't have that array yet. I've simply declared that my int array will be a reference to that. We haven't actually created it. That's why we're saying here we want an array of ints, but we don't know how many there will be because we haven't actually created the array yet. So to create the array, we use the keyword new as we would with any other object in Java. The keyword new. So here is that reference. My int array is a reference to ints, to an array of ints. And we're going to say, okay, I want a new array of 25 ints. So it's the square brackets. 25 of them, 0 through 24 for the indices. So we've now allocated an object, an array object, where it will have 25 slots or cells or whatever you want to refer to them as, and each one will be an int. Now, my int array is the reference. Using that reference, I want my int array go point at the first of the cells or slots or whatever term you want to use. The first one is the one at index 0 and assign that one the value of 42. Remember, these are ints, and 42 is an int. So we have now assigned the value 42 to the first entry in the array. Now, that would be kind of tedious if I had to write lines for that for everything. So there are some shortcuts in Java. Here we see my int array, and we don't even say how big it is. And you don't see a new. Because in this case, these braces and the numbers inside are the shorthand for allocating the array with a new and putting in a line to assign each value to a corresponding entry in the array. So this would be my int array of 0, my int array of 1, my int array of 2, my int array of 3, my int array of 4. So my, 1, 2, 3, 4, 5. There are 5 items. The indices are 0 to 4. Okay? So the first one is 11. The last one, which is index of 4, is 15, and all the other numbers in between have been set. So this is a nice shorthand. Now, arrays are objects and they hold primitives, and you can create an array for any of the primitive types or any object type because the objects are actually represented by their reference, which is a type of primitive as well. It's the 9th primitive. So here we see string array pets, and that's equal to Fido, Rex, and Princess. And that's as if we had created a new array to hold 3 things and new strings inside for each one and done the assignments. Now the string class will be covered in detail later, but I will show you some examples now of working with the primitives, and I will show you an illustration of how this stuff is allocated in memory for an example like the string array. Now, a couple of notes. I said earlier in the course when talking about the string array args that we get on main that we don't need a separate parameter to tell us how long it is because every array has a public attribute named length that we can read from. So, given my int array, I can ask for its length. That's not code I'm calling. That is a publicly visible piece of read-only data.
Okay, let's get started. Launching Eclipse from our button there is the first step, and that should bring up our environment. And the application's loading. Excellent. Now, while that's happening, I'm going to go ahead and adjust my settings to fix the display. So trim it down a little bit. And launch Eclipse in this workspace. And first thing that I'm going to do is close the welcome screen. Go File, New, and create a project. That's going to be a Java project. And it's going to be my class exercises. And have that done. Okay. And yes, I want to open the Java perspective. And I want to create a new Java package. Right-clicking and new Java package. There we go, new Java package. In my class exercises, that'll be com.lq.exercise. So q exercises. Okay. And having done that, now I'm going to create a new class named Lab2. So Lab2 will be my class. And I want to have that be public static void, and I want it to generate the comments. So, got that done. Now I'm going to implement the main method. So removing that to do here, and I'm just going to do a very simple system.out.print. And you'll notice I can select from the options presented there, and this is going to be just hello world. So done. Okay. And having done that, I'm now just going to go ahead and run it. So run as Java application and save and launch. And there's my hello world response. Okay, so very simple. Now we're going to get into defining primitive types. And I'm going to declare a number of variables with the methods associated with them. At the beginning of my main method. So give myself a little space. Okay, and let's see. Not that that's the actual value of pi, since it's irrational, but it's a start. Okay. So I've now gone ahead and defined some variables. Now I'm going to go ahead and do a few assignments. So okay. And then after my hello world, okay. Okay. And made a mistake there. I'll go fix that in a second. I should have put area, not radius. So the value of radius is plus radius, and that should be area. Losing track of what I was doing. Okay. And so I've got Width, height, area, radius, I need to do pi, system.out, print line, and it is important to remember the space before the quote so that it looks good in terms of formatting. And result is the last one. Okay. Oops, lost my focus there for a second. Got it back. Okay. So if we've done this correctly and we go ahead and run this again, so going ahead and saying run as Java application, letting it save, and expanding this out. So there you go. Hello world, value of width is 8, height 12, area 96, etc. Okay, good. And restoring it back to previous shape. Okay. And I think I'll go ahead and make sure this window is maximized within my view space here. Okay. Now I'm going to go ahead and define my arrays. So let's see. So integer of arrays. And my string array. There we go. Okay. And white space just makes it easier to read. It's not a requirement. And taking this to a new line after my comma does not break what I'm trying to accomplish. Just makes it easy to read. Okay, let me make sure I've got this right. Should be oh, typo. And that's why those messages are good, to find and fix your typos like I had. Okay. All right. And these are just warnings saying that they're not used. I've been ignoring those because I'm using them. All right. And having defined my array, now I need to initialize the days and month. So let me do that. And I have 12 to do. I'm just going to do it this way. Should be around enough. Now let's fill it in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, need 2 more. So that'll be 12. That'll be 11. Okay. Now I just need to fix the numbers. That's easy to do. February's 28. And then that'll be 30. Oops. Try that again. That'll be 30. That'll be 30 for 5. And 8 is 30. And 10 is 30. And I had one too many because I started at 0. Okay, so 31, 28, 31, 30. Yeah, looks right. Okay. And now having done that, now I need to do my printing. So okay. And let's see. That'll be month names, 0. Starting with the first one, plus space has space, plus my days and months, and it'll also be 0 because it's the same one, and space days, period, end quote. Okay, And my quotes aren't matching up. One sec. That's why. There we go. Okay, and just end that. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So oops. I'm a firm believer in copy paste when it works to suit my purposes. Okay. All right. And once again, let me just go ahead and run this as a Java application, saving it and maximizing. Okay. So that is working and done with the expected results. And it's all saved. And that ends what I needed to do for the first lab, other than the...
So let's look now at some quick code. Here is a class primitives, and I have byte, short, int, long, float, double, boolean, char, and some stuff with object and string down here just to complete the list. And you'll notice these are all paired. I have the primitive and I have the wrapper class. But we're just doing assignments from the primitive. And that's fine because we have auto boxing. Now, I'm also trying to show you here the fact that the compiler or the editor here in Eclipse is telling me that there are errors because it has checked my values. Now remember, a byte is negative 128 to positive 127. I'm trying to put positive 128 in. That is not acceptable. So it is telling me that my value is out of bounds, right? Now, if I were to change it, let's say to a negative number or simply a smaller positive number, now the error goes away and it can use this value. Remember, these literals are interpreted initially as ints, but it can look at the value and say, yes, I can take that int and put it into a smaller number based on its value. Likewise here with my shorts. I'm one too large, so I could use it as a negative number, or I can just change the number to something that is small enough, and the compiler will happily do this for me. Now, when it does so, it is allocating a byte object or a short object or an integer or long or float or double or boolean and putting the primitive into the wrapper. So it's doing that auto boxing for us. Here you see a long, and this is that syntax using underscores to separate out the values of 1 billion. Here we are multiplying that value by 10 and then boxing it up into a long. Notice the uppercase for the wrappers. The primitives are all lowercase. Now, here I'm working with floats, and the problem here is very simple. The problem is that, as the error message tells me, it can't convert from a double to a float. Now, the problem here is one of precision. Up here it was magnitude. The numbers were too big to put in. Here it's just one of precision. By default, all floating point literals are double. If you want them to go into a float without an error, you tell the compiler this is a float. So I'm simply suffixing it with an F. I could use uppercase or lowercase. That aspect it doesn't care, but I am suffixing it with an F. I tend to use personally lowercase to tell it, yes, this is a float. Now, I don't have that problem at all here with the doubles because the literals already are doubles. Here are my booleans. True and false are the available values. Here's a character. Here you see me escaping the line feed. Here I'm escaping the carriage return. So again, primitive and character. Now, the 9th primitive, which you will never know by a name in its own, but whenever we work with objects, we are working with the 9th primitive, the object reference. So here, O is a reference to any sort of object. Stir is a reference to a string, and I am assigning it directly from a string literal. And here we have a string array pets. And we have there, this is a literal array with a bunch of strings in it. Now, let's look at what that last example, our most complex of the examples, looks like in terms of memory, so you understand what we mean by references and where data can actually be stored. So, here's our string array pets. Pets is not the array, it is a reference pointing to the array. And from our example, we had 5 pets to talk about. So here is the array that's allocated, and each entry in the array has is indexed 0, 1, 2, 3, 4, and each entry in that array is a reference to a string. Now, a string is an object. So I've only drawn one, but here would be the example. So from pets, I can get to the array. From pets of 0, I can get to the string object. Now, the string object itself still doesn't hold the string data. It has a reference to an array of characters, to a buffer of characters. And each one of the characters is a primitive. Each one's a char. And here, at long last, is the M, the O, the C, the H, and the A. So when we are working with objects, you will have structures like this. This is partially why I said, whenever possible, you can work with primitives. That's going to be your ints, your longs, your numbers, basically, your booleans. Whenever you can, you're going to work with primitives. When you're working with objects, you won't have a choice. You'll be working with object references as the primitive. But that's okay. And Java's built for that. But I do want you to see what a theoretical, if you will, memory layout looks like for even just having a string array. And with that, we will conclude this module and send you off to lab. In the previous lesson, we talked about the primitive types. And the primitive types, such as int, long, boolean, char, short, float, double, and byte, they are the only places where we can actually store data. And they are the things on which operations, for example, add, subtract, multiply, and divide, are performed. But in many cases, Java has wanted to use and required the use of objects, which meant classes. Now, since Java 5, a lot of the need for these wrapper classes has been eliminated. but you should still know about them because there are a few circumstances where it is still necessary to know about and to use the class. But for the most part, when you are creating your own code, you should be working with primitives. I'll show you shortly what the overhead is of working with these wrappers. Now, what was it that happened in Java 5? In Java 5, Sun added boxing and unboxing automatic. Now, what do they mean by that? Well, here we have an int assigned to 3. Well, that's not a problem because this is a primitive. So we're assigning the primitive 3 into the primitive I as an int, and that's all fine. But this is what changed. In earlier versions of Java, long time ago, we would have needed to explicitly create an integer object to hold the primitive value. Not anymore. Under the covers, that still happens, so there's overhead, but at least in our source code, we can somewhat naively simply do the assignment. So we can say integer w1 is equal to I was a primitive, or even integer w2 is equal to 5, where 5 is a primitive. So it is the Java compiler recognizing what we are doing and under the covers hiding the fact that it has to create an integer object. In fact, W1 and W2 aren't even integers. They're references to integers. And at the end of this lesson, I will show you a diagram where we will look at what that means to have references to objects. There's an overhead here. We would have W1 and W2, and from there we would get to the integer wrappers, and from there we would finally get to the primitive values. So whenever possible, you should work with primitives. Only use the wrapper classes where you need them. Now, just like we can automatically create the integers from primitives, we can now automatically, rather than having to do it manually, extract the primitive value from the integer wrapper. So here when we say int j equals w2, what we're actually doing is extracting the int value from the wrapper and assigning that to j. Again, there is overhead here. It's just hidden by the compiler. And this makes it possible for us to largely ignore the fact that there are differences between the wrappers and the primitives. So whenever possible, you use the primitive. It'd be much more efficient. And when it's necessary to have a wrapper, we'll let the compiler do some of that work for us. In this module, we'll continue our look at Java language fundamentals, specifically in this case, flow control. Now, we'll look at additional aspects of the Java language syntax. In order to talk, for example, about flow control, we might need to talk about comparisons. So we're going to look at the various built-in operators, not just the logical or comparing operators. We'll look at them all. We'll look at writing simple Java expressions. And so this lesson will focus on operators. The next lesson will focus on then branching. If this condition or if this other condition. And we will look in the third lesson of this module at looping. Repetitively doing something based on how many items there might be to process or until a condition or while a condition. So operators perform in general in Java on primitives. Okay? So we're talking about being able to add, subtract, multiply, divide. We're looking at comparisons less than, equal to, greater than. Now notice I said primitives. When we're talking about comparing objects, we're going to learn that what we really need to do there are use methods, not the individual. So look, things that look like functions, not the methods, the symbols for comparison. Now, syntax is going to be fairly straightforward and maybe already be familiar to you in terms of the use of operators from just your basic math, okay, or other languages, since this notation is fairly common across many different languages. One of the operators we're going to talk about, and I would say not probably, but certainly the most common operator in Java, is the dot operator, which is the one that allows us to access the members, whether it's data or methods, of an object. Right? So if I have an employee and I want to refer to the employee's department, it might be, my employee dot get department. So the dot was allowing me to access the get department member. So here are operators in Java. We have assignment. We have addition, subtraction, multiplication, division, and the percent is if we're dealing with integers, then when we divide, let's say we divide 12 by 5, well, the answer is 2, but the remainder is 2, right? 12 in integer terms, 12 divided by 5 is 2, which is only 10, but there's a remainder of 2. We have increment and decrement. If I have a number, if I have an integer and I want to increase it by 1, so I could say plus plus I. If I wanted to subtract it by 1, I could say minus minus I. So plus plus and minus minus. And those can go in front of or behind to the left of or the right of the variable that we're trying to increase. If I put it to the left of the variable, plus plus I, first it will increment I, and then the resulting expression will be the increased value. On the other hand, if I were to say I plus plus, and sometimes we do that, for example, in a loop with an array index. If I say I plus plus, first we use the current value of I, and then it gets incremented. So it matters significantly whether it's plus plus I or I plus plus. Pre-increment or post-increment, depending on whether you have put it on the left-hand or right-hand side. Relational operators. Less than, the double equal, can notice the difference between assignment. The double equal is equals as a comparison. The greater than, less than or equal, greater than or equal, not equal. And again, these are going to be useful with primitives. If you try to use this with objects, what you'll find is, well, it doesn't do objects. What it does is primitives, and so you'd literally be comparing the reference value, which is basically worthless. The only use for that, if you literally wanted to know if two objects were the same or are not the same, then it would be comparing the two references for equal or the two references for not equal. But this is why you'll find that we have methods for comparing objects, not the operators. So, as in the last module when we talked about primitives, these operators compare primitives. Now we also have logical operators. ANDing, ORing, and a NOT. So logical operators, we're dealing with Boolean values or Boolean expressions. Is this less than that and some other value greater than another one? That would be the double ampersand between the two comparisons. What about, is the department HR or is the department IT? Well, now I'd be using the ors to compare. What if I want to say Joe is not a manager? Not. So I'd be using the negate so that Joe is manager, not it. Put not in front of it. Not Joe dot is manager. Now, we also have the ability to do bitwise comparisons. So, anding at the bit level, oring at the bit level, complementing at the bit level, exclusive or at the bit level, shift left, shift right, and another shift right because we're dealing with, when you shift left, you're always bringing in from the right hand side a 0 to replace the value that you just shifted into the next bit position. But what if I'm shifting to the right? So the question is, am I shifting to the right without taking the sign into account or with taking the sign into account? And that's why we have two different shift operators. The two symbol version is the signed right shift. And since we are working with signed numbers exclusively in Java, it's the common one. But you may have some cases where you don't care about the sign bit and you want an unsigned shift. So the leftmost bit other than the sign will be a 0 as you shift. And so that's what this version does. Now the dot notation or the dot operator is for accessing members, whether they're attributes or method, for the particular instance, the particular object. So here is a look at the assignment operator. We have two integers, two primitives, although as you may recall from the prior module, we could use auto boxing to put them in. So, and put them into an integer, but we'll stick with our primitives. That's what we recommend. So here's I equals 42, j equals 21. I is overwritten with 21, and now I is going to be overwritten with whatever the current value of I is, plus the current value of j. So looking back at our code, it'd be 21 plus 21. That is why the result is 42. Now we have the standard set of math operators: add, subtract, multiply, divide, and for integers, otherwise known as whole numbers, modulus, which you may remember from school as the remainder. There's unary plus and minus. That's not the plus plus stuff. This is like a sign change, right? So typically more used with the minus, but unary versions of plus and minus. Now, the precedence of these operators, they're referred to here as binary, not because it's binary math, but because they take two parameters, one on the left, one on the right. And as you may recall from mathematics, the multiply family goes first. Add and subtract has lower precedence. Okay? And I said multiply family because you may recall that division is multiplication by the reciprocal. Just like subtraction is addition of the negative. The unary operators, the plus plus and the minus minus. Pre-increment, pre-decrement, post-increment. So first we'll use the I, then it will be incremented. and post decrement. And you do want to be careful about these, especially if you're using the value in the same expression in which you are incrementing or decrementing. And I gave you the example earlier in this video of using I as an array index. Well, did you want to increment the array index first and use the incremented value? Or did you want to use the value first and then increment it for perhaps a subsequent use? Relational or comparison operators. Less than or equal to, equal, not equal, greater than or equal, and greater than. The result of these operators will be a Boolean, so true, false. Doesn't matter what you were comparing here, ints or floats or other, primitives. And again, be careful trying to use these with objects. You won't get what you expect unless you expect to be comparing only the primitives. But the result of these will be a Boolean, a true false, which we can then use with our while loops or our if statements. Now, if you're not familiar with the and, or, exclusive or, and not, this table will help you out. So given the two values of x and y, not x is the opposite of x. So true, true becomes false and false here. The false becomes a true. Now all the others are binary operators. So we need the y column as well. So x and y requires that they both be true. If either one is false, the result is false. Whereas in or, only one of them needs to be true for the result to be true. In order to be false, they both must be false. Now, exclusive or is an interesting one. If one of them is true, well, then it's true. If neither of them is true, it's false. But the difference between exclusive or and a regular or is that if they're both true, instead of being true, exclusive or says they're false. It's exclusive or, which is why both of them being true makes the result false. Now, in general, we will use double ampersand and double pipe or symbol. And it refers to those as short circuiting. Because you're saying and. Well, if the left-hand side of an and is false, it doesn't matter what the right-hand side is. So Java will not evaluate the right-hand side, having already determined that the left-hand side is false. Likewise, if the left-hand side of an or is true, well, it doesn't matter what the right-hand side is. The left-hand side's true, therefore it's true. So just like the double ampersand will not evaluate the right-hand side if the left-hand side is false and it short circuits, the double or will not evaluate the right-hand side if the left-hand side is true. If the left-hand side's true, doesn't matter what the right-hand side is. And with the and, if the left-hand side is false, it doesn't matter what the right side is. The single ampersand and pipe do not short circuit, and in general, we don't use them for logical purposes. We use the short circuiting operators pretty much exclusively. Now, when applied to numbers, these are bitwise comparisons, right? And or, I mean, we said, well, they could be logical or they could be, binary. Well, these bitwise comparisons, that's when it's their integer type values, right? Bytes, shorts, ints, and longs. It will be a bitwise comparison, which means each individual bit will be set according to whether or not the 7-bit in a byte, for example, if they're both true, if the 6-bit in 2 bytes, are they true, right? So that's what we're talking about. Each bit, you line them up in columns and perform the operation. And each column will have its own result individually. So here's some examples. X is 7, Y is 9. Is X less than 8? Well, yes. Now this is an AND, so this is true, and that's an AND, so we got to keep on going. Right? Because they both have to be true to execute the statement inside these braces. So X is less than, 7's less than 8, 9 is less than 10. Both statements are true, and therefore we would execute whatever is inside the braces. Now here is a different notion. The result, this is a variable, a Boolean variable, and we're assigning it to the result of this Boolean expression. So is X less than 8? Well, yes, 7 is less than 8, and this is an OR. So true or, well, we don't care. So it will never even check to see if Y is less than 3, because this is an OR and the left-hand side is true. 7 is less than 8, therefore B is set to true. Operator precedence, and these are blocked into groups of equal precedence. So we have increment and decrement, pre and post. The associativity of these is from right to left. We have the unary pluses, all of these considered at the same level of priority, right to left association. Then comes the multiply family, left to right association. Adds and subtracts, the bitwise shifting, comparisons and type identification. Look, we try to avoid type identification as much as possible, as we'll learn about when we get into object-oriented programming with Java and we understand what polymorphism is and inheritance and interfaces. But there are some things we just can't avoid, and occasionally when that happens, we may need to make sure that we are literally doing, if you will, an apples to apples comparison. So we may be in a position where we're forced to take an object and make sure we know exactly what type it is, and that is what instance of will allow us to do. Next comes the check for equality or inequality, followed by the bitwise operators, the logical operators, the ternary operator, which we will cover momentarily. And then you'll notice now that we've got a whole bunch, the lowest priority, we have a whole bunch of assignment operators. Now, you're familiar with equals. You may not be familiar with the others. So we're going to take a quick look at those. These plus equals, minus equals, multiply equals. So the way in which you would understand them, the basic idea of these operators, is that if we have x op equals y, right? That's a shorthand. It is a shorthand that is equivalent to x equals x op y. So for example, x plus equals 5 is saying x equals x plus 5. Here's a live example. I is set equal to 10, j is set equal to 12, I plus equals j, and the result that we see live is 22. we have an expression. It's known as a ternary expression because the operator, the question mark colon, is known as the ternary operator. Now, the way this works is you have a condition in front of the question mark. And if that condition is true, then whatever expression doesn't have to be just a single value. Whatever expression is between the question mark and the colon is evaluated. And the result of evaluating that expression is the result of the overall expression. And if the thing in front of the question mark here, if x is not greater than 7, then whatever comes after the colon is evaluated and it will be used. Now, we could have done this in an if statement. We could have said int y. We could have said int y and then said if x is greater than 7, y equals 2, else y equals 5. But that's more code, more verbose, and less clear. It sort of buries the lead that the whole purpose is to do an assignment to y. This, while it may take some getting used to, preserves and makes explicitly clear that the goal of this line of code is to assign a value to y. It's just that it happens to be a conditional assignment to y. Okay? So, we're going to assign to y. What are we assigning? Well, if x is greater than 7, assign a 2. Otherwise, assign a 5. Okay? By their very nature, they short circuit. We'll never evaluate whichever one of these two possibilities is not selected by the condition. So this is not an if statement, it's an expression. It results in a value. It's just that the value is conditional. In my personal programming, I tend to use these fairly often. You'll see what it's like for you as you go through your development career. Now, completely new concept is a switch. A switch is not based on a condition. It is based on a comparison of values. So, we are going to say switch, and then we will have case and a value, and then statements. You're going to have more than one in here. This is going to be where it says statement 1, statement n. Think of it like block 1, block 2, block n. You can have many statements there, as we will see in a more complete example coming right up. Okay, so case and a value. Case and a value. Case and a value. Now, where do the values come from? Well, we're going to evaluate an expression. Now, the expression results in either a number or, as we'll see from, was added to Java, the ability for it to be a string. But one way or another, this expression results in a value, and that's what these labels are. They are the values to check. So if I say, if I have a label here of 1, 2, and 5, and we evaluate the expression and it's a 1, then we're going to come here to this case and start executing. If it's a 2, we'll come to this other one. If it's a 5, we'll come to this one. And if it were a 3, well, that's not the 1, 2, or the 5, so we would go to the default. So it tells us where to jump into this list of statements to execute. So here, switch wattage. So wattage is a value. Simplest form of expression is a single value. And here we go. Based on the value found in wattage, if it's a 40, start here. If it's a 60, start here. If it's a 100, start here. If it's a 150, start here. Otherwise, if it's something else, come to default. Now, you noticed I used the words start, right? Start here, or start here, or start here. Based on the value, we find the matching case, and we start executing top to bottom from there. Now, here we have price equals 1.2, so 120, and there's this break. Break is used to terminate the switch statement. We now go to the end, we're done. So we said price equals 120, break, and we come on down and we're done. In the case of 60, price is 130. We see the break. We come on down and we're done. The next one is sort of a simple case of saying, okay, come here if it's 100. Now, 100 doesn't have anything of its own. We're just going to put 100 and 150 together. So it's sort of, they're giving the example of falling from the 100 through to 150. So either of those, the price is assigned to 115, break, and we're done. If we come to default, we'll handle that. We don't need a break because that came at the end, and we just fall out and we're done. Now, if you leave out, and this is a common programming error because you can take advantage of it to your benefit, and there's some classic examples of that. We'll put in a reading for Duff's device. But there are some classic examples of deliberately falling through a switch statement through many cases. If you forget to put a break, if we were to forget to put a break right here, for the case 60, what would happen? If the wattage were 60, it would come here, start executing price equals 1.30. If this break were not there, it would continue to execute until it found the break or until it reached the end of the switch. So when you are using switch statements, it will be important for you to put breaks in. It will be the norm to put breaks in, and anywhere that you do want a deliberate fall through that is anything more complex than just a few cases in a row and one set of code, you should have an explicit comment where somebody might have expected to see a break statement. So you should tell them, this is not an accident. I didn't forget to put a break. We intend for this code to fall through. Now, this is that programming language update on the switch. Java 7 allows us to use a string value. So here, switch day of the week, and if it's a Monday, if it's Tuesday, Wednesday, Thursday, notice the fall through. If it's Friday, if it's Saturday or Sunday, and otherwise, so here we're checking, there's a specific list of possible values, and the default, rather than being used for something, a value that we might have had, is actually being explicitly used to handle anything that's an improper value for the possible range of values we have here. There are only 7 days you could possibly have had. And so they're actually throwing an exception. We'll talk about exceptions much later on, but we're here throwing an exception to say, whatever this was, that's not a valid day of the week. Okay? So this function will take a string that's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday, and will return start of work week, midweek, end of work week, or weekend, depending on its categorization, right? Based on the day of week string. So this is the Java 7 extension to the switch statement. When I am looping, there might be something about the data that wants me to stop looping. Okay? Now, that could be in one of two ways. When you say stop, what do you mean? We could completely exit the loop. That will be the break statement. So, we're looping through on a count as long as it's less than or equal to some maximum value, we'll process the first 50 lines of data, whatever this might be. So while the count is less than or equal to the end value, read the next chunk of data. Now, if the data we just read in has some, now this should be double equals, has some bad value, then break. Okay? Then abort this whole loop. So whatever that bad value is, it's telling us, no, we're not going to do anything. Abort the whole loop. Otherwise, we would print out the count and continue to loop, because you'll notice this system out should be indented just a little bit. Okay? Now, what if instead of completely breaking out of the loop, we just wanted to go back to the top of the loop and start the next iteration, aborting the remainder of this iteration, but not the entire loop? For example, let's say I was looping over the contents of a file and I came across a comment line or a blank line. So rather than processing the whole line, let's just go get the next one. So that is the idea of the continue statement. Now, continue works in while loops and also in for loops, and says, okay, whatever was left in this iteration, we're going to skip. Let's go straight back to the top of whatever kind of loop we're in and see if it's time to go again. Or I suppose in the case of a do while, go straight to the while part to see whether or not we're going to do the next iteration. So, count equals 1, count less than or equal to 10, count plus plus. If count is equal to 7, continue, which means skip printing the 7. Skip doing whatever else might be down here, still inside the loop, and go back up and get the next one after the 7. Okay? So that's why we get 1, 2, 3, 4, 5, 6. We don't get the 7. We get the 8, the 9, and we do get the 10 because it's less than or equal in our condition. And then on the 11, right, having done 10, we'll increment to 11. The condition will fail and will drop out of the code. And so that's how continue works. And break and continue are going to be very useful to you in your programming. I've tried to give you a few realistic examples, such as processing the lines in a file and wanting to skip processing things that are things like blank lines or comments or just something you don't want to process. And it's going to clean up your code a lot more than saying, oh, if it's not a comment and having a big if statement for the body of the whole loop, just to skip processing the things that you didn't want to do. So this is a very nice controlled mechanism with continue and break. Now the for loop, you'll notice that in our while cases, the whiles were built off of the idea of counting, right? That's what we were checking. We were checking a limit and we were counting. So our for loop is designed for that case rather than, having to do the counting in the loop the way I did. Here we say for int equals I, so we're actually even declaring the variable in the for loop itself. For int I equals 0, semicolon. So this is the initialize part. And these can become more complex. We could initialize multiple variables there, and they don't have to necessarily be counters. Okay? So, initialization, setup of variables. So here we have an int I assigned to 0. This is very typical. And then we have a test. In this case, I less than 10. So we do the initialization step, then we execute the test. If the test is true, then we execute the statement associated with the for loop. Once again, because we've used braces, this will be a compound statement, otherwise known as a block. Now, so do the init, do the test. If the test is true, execute the block. Then, having executed the block, we come back up and we do essentially an increment step, the post that they're talking about here. And again, this can also be more complex. All three of these could be more complex than we're showing. Okay, so in this particular case, we're going to increment I. So having executed the body and done the post step, then we do the test again, and if the test is still true, we'll execute the body again, do the post, do the test, exit the body. So the pattern is you do the init just once, you do the test before every loop, and then after the loop, you do the post, and then recheck the test before doing the loop again. When the test says false, that is when we exit the for loop and continue on past it. So this is a counting for loop, and when you're doing counting, rather than doing the while loop that like we saw, it is best to use a for loop. While loops are better for other sorts of conditions rather than counting conditions, rather than, enumeration conditions, as we'll see coming up. So here's a slightly more complex example. The initialization, and we could have also had the int in here, but they declared it first. So here's the int. Int I is 0, int j is 2. We are comparing simply to see if I is less than 10. And at the end of each iteration through the loop, we'll do an I++, and we'll increment j by 3. So j plus equals 3, right? Now, for a long time in Java, when we would go through collections, right? I can have a collection of objects. I can add things, I can get things out of the collection, and so the way we would tend to do that would actually be with a while loop. We would say, we would get an iterator for the collection, and while the iterator says has next, it's got another one, while it's got another one, go through the loop, get the next one, do something with it, come back up to the top of the while loop or at the bottom of a do while and say, okay, is there a next one? And if there is, then we would go get the next one, etc. So they introduced in Java 5 the for each loop, otherwise known as the enhanced for. Okay, this is to make it easier and more consistent going through not just collections but arrays. They unified looping through any of those sorts of things. So this is the for loop that you will probably use most often. Okay, so the syntax of this is for and then some type, whatever this collection is a collection of. If it's an array of ints, well, then it would have been for int and then the variable name. If it's a collection of employees, then it would be employee and some variable name to be used in the loop. And again, the particular collection that we're looking at. So if I had a department object and the department object said that I can get employees and it would return some form of collection of employees, I would be able to say for employee emp colon department dot get employees, and this loop would go over every employee in that department. So we don't have to write the code for getting the next one and seeing if there is a next one and worrying about the difference between how you would loop over an array versus how you would loop over some other type of iterable thing. As long as whatever this thing labeled collection supports iterable, which is a particular interface in Java, this for loop will work with it. You could create your own things. We could do it with for message m colon q dot messages, and somebody could make sure that if I went to get the messages from a queue, whatever from a messaging queue, whatever that object is supports iterable and lets me get the next message and the next message and the next message. An easy way of going over a file would be to have an object that lets you, every time you get the next thing, it lets you iterate over the lines of a file. So that's where this comes from. Okay, that's the goal of this sort of for loop, is to make it very easy and very generic to just loop over things that are iterable, that have elements, that you can get the next one, the next one, the next one, until it's empty. And this is a wonderful programming construct to have. So here's an example of this. We have a string array called SA, and there are some strings. So for each string, that's how you might read this to yourself, for each string S from the string array, go print out S. Now here they've converted S to a string. We'll learn about toString later. In this case, it's kind of a bit redundant since it already is a string. Now, here we're doing the same thing, right? We have an integer array. Now, those are objects. For each integer I2 in the array IA, go get it and get the int value. Now, this is one of those cases where you don't have to do this anymore, right? Because of the auto unboxing, it will automatically go ahead and grab the value for us and let us print line. Okay? So you don't have to do that anymore. It will continue to work. The while loop will evaluate a condition, and as long as that condition is true, the while loop will execute the statement that comes after the while loop. Now, just as we saw with if you want to have more than one statement, you would use braces to designate a compound statement. So here we start with the count equals 0. We start with n of 20, and while count is less than n, so while count is less than 20, we will print out an asterisk and increment the count. Now, this condition is based off of this count plus plus. Now that's kind of dangerous because they are separated by other code. Now, it doesn't mean we don't write code that way, but the further your condition code is from the things that affect the condition code, the harder it can be to debug. So, in this live example that I've set up, you'll notice it's very similar. Here's count equals 0, n is 20, but now it's while count plus plus is less than n. Now, as we execute this, it'll first compare count and n. The plus plus comes after we've looked at count, not before. So it will compare 0 with n, 1 with n, up through 19. Eventually we'll check 20, and 20 will not be less than 20, so that's where we would stop. And if we run it, here is your output. Now, one thing to note, this is system out print. Up until this point, we've been using a lot of print lines, which add their own line terminator. This is just a print, and that's why the asterisks all come out next to each other. So that is this while loop based off of a condition. Now, there's also a do while loop. Now, the difference here is that in the while loop, which we saw on the prior slide right here, we evaluate the condition first. And if the condition were to be false, we would never run the body of the loop. Here, we run the body of the loop before we check the condition. So the difference here is we always run the body of the loop at least once, and then we continue to run it as long as the condition is true. Okay? Other than that, they're identical concepts.
All right. So if you have done exercise on flow control, that set of exercises in that lab, then you should have something that looks similar to what I'm about to show you. There were several exercises involved in this. First, of course, creating your Lab 3 class, and then inside of that, creating your days of week string, and let me blow this up a little bit better. There you go. So there's my days of week string, and later there was another piece where we pulled in from the previous exercise the month names. So I just copied and pasted from Lab 2, my class called Lab 2. I pulled that out from it. Anyway, so first part for exercise 1, days of the week, just in a simple for loop. Second part for exercise 1, use an enhanced loop for days of the week. Okay. Third part for exercise 1, do a reversed loop for days of the week. Then exercise 2 for this lab was to use a while loop and the continue option to escape out of that while loop. Okay. And then the third part of this lab, exercise 3, is to use a for loop to have the numbers between 1 and 100, except for 50 through 60. So if it was greater than 49 and less than 61, I skipped it with a continue. Okay. And then we had exercise 4 in here doing a switch statement in a while loop. So there's my while loop. And this is where that month names came into play to create a while loop that was going to specify which months have 31 days, which have 30, and which have 28, and ignoring leap year. Okay. And finally, had the challenge exercise, which I went ahead and did as well, where printing the month of March, specifying that it starts on a Friday, so skipping days 0, 1, 2, 3, and 4, so up through Thursday, and printing out that calendar. And how does all this look? Well, if I go ahead and run it, run Lab 3, and just pull that all up, you can see. So there's the start of the output for exercise 1, standard loop, Sunday through Saturday, enhanced loop, Sunday through Saturday, reversed loop, Saturday through Sunday, exercise 2, 2, 4, 6, 8, 10, 12, the even numbers up to 20. Exercise 3, 1 through, and you can see it went up to 49 and then skipped to 61. So skipped 50 to 60 up through 100. And finally, exercise 4. There are the number of days for each month for January through December. And there's my challenge exercise for a month of March, starting with the 1st on a Friday. Okay, so if you have something that came out similar to this, you're in good shape.
In programs, we often need to make a decision. We want to execute code conditionally. This is the if statement in Java. So, we are using relational operators generally, not always. We may have a function that has returned something. What we need is a Boolean, if true, right? So, if x less than y, depending on the values of x and y, if that Boolean expression is true, then we will execute the statement that follows the if statement. Now, it could be a single statement. When it is more, when you want more than a single statement, you have to create what's called a compound statement. That is the use of these braces. What's inside the braces is the single compound statement that will follow the if. Okay, so with an if, it's a condition and a single statement. We use braces to create a compound statement when you've got an entire, as they use the term here, code block or block of code to execute. So if x is less than y, we will print out this message, we will perform this assignment, and we will then continue on. So only if the condition is true do we execute the statement. Okay, here is that example of a single statement, right? Since we don't have the braces here, only the one statement after, which is what the braces basically do. They group things into a single statement. The one statement after the if. Now, indenting or otherwise, it's still the one statement. Even if we indented the second print line statement to be exactly lined up underneath the first, it wouldn't make a difference. Indentation does not matter in Java. Okay? It is the language construct. And if takes a single statement to perform. That's why we use braces to delimit a compound statement. The slide is in fact even suggesting here that even in the case of a single statement, it would be best to use braces for clarity, or in case somebody comes along and adds another statement and doesn't realize what's happening. Okay, so yes, you can do it without. Personally, if I'm going to do this, I might even put the single statement on the same line as the if. Okay, to make it less likely someone would come along and just continue to add indented statements, even though they won't behave the way somebody might have expected, because they're indented. Without braces, doesn't do what they think. It might be the case that we have code to execute if a condition is true, and different code to execute only if the condition were false. So that is the use of an if with an else. If cash available is greater than the sale price, then let's go ahead and buy it. If available cash is not greater than the sales price, then save some money. By the way, I will point out to you that this is a classic example of an off by one error. Because if available cash equals sales price, you can also buy it. So it actually should have been available cash greater than or equal to the sales price. Okay? Now, those sorts of problems come up all the time in code, enough that it's literally, there's that phrase I used, it's almost a cliche, it's a meme, an off by one error. Okay? So whenever you're doing comparisons, just remember this example and consider, is it less than? Is it less than or equal to? Greater than or equal? Is it, do you have an off by one error? Okay. So the save more money only happens if the condition were false. And the let me add it only happens if the condition were true. Now, here we're doing exactly the same thing, but the braces exist to create compound statements. So x less than 7, and we will print, assign, and assign. We'll do the calculations. If x is equal or greater than 7, then it's not less than, we print out, and we do a different set of calculations. Now, the indentation is not necessary, but the braces are. The braces are part of the language construct. The indentation is there so that we as humans can read it correctly. Now, sometimes the indentation may be misleading and wrong in the way it's done. And fortunately for us, we have tools, for example, built into Eclipse that will reformat and re-indent code so that the way it works will be reflected in the indentation. Now, we can have if statements and other kinds of statements inside ifs, right? Inside an if, we can have an if or a while, or there's no limit to the ways in which we can mix and match and nest things. Okay? So here we're saying if x is greater than 3, well, print out that message, and eventually we're going to do a decrement of x. But while we're at it, if not only is x greater than 3, but also y is less than 10, then we'll print out this message and do this other calculation. So you can nest these things. On the one hand, the source code might become more difficult to read. On the other hand, how else would you want to do this in a manner that were more readable? Sometimes the bottom line is you have a more complex situation, and so we make it as readable as possible. And with practice, these things are really not difficult to read. They're just more difficult on some scale than a simple non-nested if statement. We've already looked at the case where we said, if this condition, do something, otherwise do something else. Well, we may have multiple of those to compare, right? Multiple sets of conditions that are exclusive. So, if x is less than 3, do this. Else, well, remember, else takes a single statement. The single statement that else is taking here is another if. So if x is less than 3, do this, else do this next statement. This next statement is in its own right an if. So if x is less than 6, we already know it wasn't less than 3, but if it's less than 6, do that. Else, well, then neither of these were true, so print out that it's some other message.
Control Lab. And adjusting my display settings. And launching the lab workspace. All right, and there's my lab 2 that I've already done. Let me just close that. And let's see. So I'm now going to create my next lab. class, which is going to be called Lab 3 in the com.lq.exercises. So just new class, and this is going to be called Lab 3. And again, going to have a main method. And I'll go ahead and generate comments again. All right, so there's Lab 3. And first thing that I need to do in terms of the exercise is to create an array of string references named days of week and initialize it with the names of the days of the week starting with Sunday. So I've got my public class Lab 3, and let's go ahead and create those string arrays. So string is going to be an array, days of week equals, and Sunday, day, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay. And close out that array. So and forgot to start the array. So there we go. So curly brace. And okay. I think that's right. Let me see. It's my error message here. Okay, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That part looks okay. Oh, I have strings rather than string. My bad. Fixed. Okay. And that removes the error and converts it to just a warning that it's not being used, which is fine. Okay, and I also need to have my exercise to print out the days of the week. Okay, so using a for loop. All right, so go ahead and do that. Just keeping track. So this is going to be for my standard loop. So okay. So if I've done this correctly, should be able to just quickly run this. And there's my expected results, Sunday through Saturday. Okay, good. All right. And now I'm going to do the same thing, but I'm going to use an enhanced loop. So, line. Okay. So, okay. So, not quite what I want. Okay. Oh, my bad. There we go. And that's better. Okay. So, done using the standard loop, done using the next construct. Now, need to do another loop to print out the elements of the array in reverse. Okay. So, let me do that. Okay. So starting with the seventh element, which is 6, down to 0. And there we go. All right. And go ahead and run that. Make sure it's working properly. Saturday through Sunday. Okay. So standard, enhanced, and reversed. Okay. All right. Now, having done that, I want to do exercise 2, which is to use a while loop to print out even numbers between 1 and 20. Okay. Add a blank line just to separate it and indicate that this is exercise 2. And start with 0. So just have an initial count of 0, and then while count is less than or equal to 20, increment count, and we're looking for even numbers, so count modulo 2 is 1. Then it's odd, so I'll just continue and escape out. And if it's not, whoop, then I'll print it out because it's even. All right, let's see if that works. I think my logic's right. Okay, I have an error. Let's see what the error is. Oh, yeah, my bad. Don't forget your semicolons. So all count is less than or equal to 20. Statement count. Count modulo 2 is 1. Open statement. Okay. So you can always go to the problems as well here. Okay. And I'm just looking to see where I have my error. Version 2. Continue. Okay. Okay. All right. Let me see what's going on. Expand out this error message so I can see it more clearly. Can't convert from int to Boolean. Oh. Okay. Now, why is that trying to convert it to, oh, that's why. Okay. I'm missing my parenthesis. Okay. That's what gave it away. The fact that I had it as this is an integer, but the expression is what's true for the if. Okay. All right, now I can go ahead and run this. And my logic was still sound. So 2, 4, 6, 8, 10 through 20. All right, good. Okay. And continuing on. So exercise 2, step 5 was to use the create while and a continue statement in an if. So skip the odd numbers. Okay, good. Now, exercise 3 is next. I've got to print the numbers between 1 and 100, stopping after 50. Okay. That's simple enough. So, skip a line, I think, just to separate it out. Line. Also giving it another line. So, start of output for exercise 3. All right, and now I'm looking at for some integer. Let's see, I've done I, J, let's do K equals 1, K less than or equal to 100, right? And let's just get some separation there. And increment K. All right, and so in my for loop, I want to have a conditional, because if K is greater than 50, I don't want to print it. So if K is greater than 50, and of course if K is less than 100, no, what was the, if it's between 50 and 60, I don't want to include it. So if it's less than 61, okay, there we go. Okay, so I'm going to skip those, just continuing out of the loop. Otherwise, I will print them out. So system out print. Okay, and a space. Okay. And what did I just get an error with? Oh, system dot out print. There we go. That looks right. Cleared up my errors and run that one. Okay, and let's pull it up and look. So 1 through 41, all the way up to 100, and 49, 50, and then skip from 50 to from 51 through 61. From 50 through 61. No, that's wrong. I don't want 50. So I want 49 through 61. So minor fix. And I should be good. If it's greater than or equal to 50 and less than 61, or just greater than 49. Let's just do that. Okay. And yes, you can just click on that disk icon up there to do the save if you don't want to have it ask when you do the run. All right, so if I've done that correctly, yep, 47, 48, 49, and then skipping 50 through 60 and continuing with 61. Okay. Okay. So that's exercise 3, and exercise 4 is next. All right. So system.out.println, and do another new line. Start of output for exercise 4. Okay. And exercise 4, let's see. Number of days in each of the months of the year. Which means I need the month names in place. If I'm going to, oh, and that's part of step 11 in exercise 4 to print out the name of the month as well. So let me go grab out of lab 2 that string that I had where I had defined the month names. There's no need for me to type that back in. Okay, and I'll just paste that in here. Okay. All right, so we're using a counter starting at 1, and we're going to increment that. Okay, so month count is going to start at 1 by definition. Now, while month count is less than or equal to 12, now I'm going to use a switch statement. On month count, okay, and let's see. I need to indicate the months of the year. They contain 31 days, not worried about leap years, and the ones that have 28 days or 30 days. Okay, I can do that. So, which days have 31 days? Let's see. January has 31. March has 31. May has 31. July has 31. August has 31. October and December. So those all have 31 days. And therefore, I'm going to just say for, whoops, those should be colons, not semicolons. Helps if I have the right syntax. Okay. All right. So for all of these cases, there are 31 days in add my space and put in my month names. Helps if I have it capitalized properly. And that's the month count. Minus 1, because my array starts with 0. Okay. And that'll help if I actually have that spelled correctly. There we go, month count. That gets rid of all those errors that I was seeing. Okay. So now I want to break, because now I'm looking at those cases where the number of days is 30. So not February, but April, June, again, helps if I'm doing this right, with colon for each case, and September, and November. All right. And those will all be 30 days. And silly to type all that in when I can just copy and paste. So there are 30 days in those months. And then finally, February. "28 days, because I'm not worried about leap year. And just in case there's an error and it doesn't fall into my range, error, it's an invalid month number if it's not between 1 and 12 for this particular piece. Okay. All right, and close that off. Increment my month count. Close that. Okay. Did I have a typo? I had a typo. Okay, that happens. So I like copy and paste. Okay. And okay. And I'm going to just say to run it by using the bar, which I can also do. And let's look. So exercise 4, new, it's on a new line, right? January, February, March, April, May, June, July, August, September, October, November, December, and 31, 28, 31, 30, 30. Yep, that's all right. Okay. So that's using our switch and case statement. Okay. And there's a challenge exercise, which we can do. Print March as a calendar, where we want to have heading with the days of the week. 5 rows with the days of the month in the correct column, assuming that March 1st starts on a Friday and flowing Sunday to Saturday, left to right. Okay? So we want that to do the system out print, printing the information without doing print line, because we don't want a carriage return after each print. Okay, so let's go ahead and try to do that. Sorry about that. Okay, so let's try to do that. And this will be system out print line, new line, and start of output for challenge exercise. Okay. All right. So we're going to start printing we've got 5 lines of information. We don't start printing until Friday. So we skip Sunday through Thursday. So 0, 1, 2, 3, and 4 will be skipped, starting on 5 and then 6 on a array of 0 to 6 for the 7 days of the week. Okay, so let's just create a variable here and call this left off. I'm going to say it's going to be 4. Now let's put in a comment. Okay. All right, and let's put in a Boolean so that we know, are we printing or are we not printing? And we'll default that to have a false value. Okay, and what day of the month? So day count, starting with 1. Actually, not day of the month, that's going to be the day of the week. So we'll call it okay. And now let's start by printing Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now, each of those is 3 spaces, or 3 characters, plus a space, except for Saturday where I don't have the additional space. So all my numbers will have to fit inside those uh, 3 digits as well. That's fine. I can easily do that. I can print a space followed by the number, which is going to be I'll have to format it properly, so I'll have space, digit, digit, space. And if it's a 1-digit number, I'll just have a second space. Okay, I can do that. So helps if I have that in there correctly. Okay. Typos are the bane. As you've seen, these things are not yet in use. That's why they have warnings. Warnings are fine. Errors are not. But it's easy to figure out what the errors are, or somewhat easy once you get the hang of it. Okay. And for an integer, and let's use y for the lines, because I'm going to have 5 lines. So start with 0 and less than 5 and increment y. Okay, so starting with 0, less than 5, so there's my 5 lines, right, for my little calendar. And that's the lines. Now, that's the lines of my month. Okay, and then I'm going to have the days of the week. So, x equals 0, x less than 7, increase x. Okay, and okay, now the question is, how do I handle my printing? Okay, so if I'm not printing a number, then I'm going to print, not print line, 1, 2, 3, 4. Okay, so this is the spaces that's going to print prior to the first day. Okay, So what did I say? If we're skipping the first 0 through 4, so the first 5 days. So if x equals my amount that I'm skipping, at that point I'm going to turn on my printing. Okay. So that takes care of if x equals that. But what if printing does not equal false? Okay. Then if the day count is less than 10, okay, because I need to have an additional space for days 1 to 9. Okay. System.out.print. And this is going to be my day count plus 1, 2, 3. Oops. Inside the quotes. 1, 2, 3. And that'll work better if I use the right variable. Okay, good. And there's no, there we go. I had an underline there. My bad. Okay, so if it's okay, and day count increment. Okay. Otherwise, and let me just copy that. Whoops. And remove one space. Okay. And I want to finish it up. with, I could have just done a print of /n or a print line. Doesn't really matter. Same results. Okay. All right, and save and run. And how'd I do? Starts with Friday. That looks good. And this is for March, right? 30 days. All right, that completes the exercise. Hope you found it worthwhile.